here is our project Words to by Shop by, and I'm Tiffany Wong.
My name is Tan Vu.
And I'm Robert Barrett.
So here's our outline of the project. First, we have our research goals. The first one is to find out what parts of products reviews are most essential to the product ratings. And the second, we would like to see if these principles hold up across multiple product categories.
So our methodology, we broke down the problem into 3 sections. First, we want to create a table of terms, describe their frequency and their weighted average rating, and then plot these into charts. Second, we want to create a machine learning algorithm to see how closely these results were related to their star rating. And we did this with both data sets and used the mean squared error functionality to test the validity of our model. And third, we used natural language processing to detect the relative frequency of word types, such as adjective, noun, and verb, and their frequency within the ratings. We did this in CSE, an additional package. So for frequency, we found that it looked different between Amazon tech products and women's clothing. What's interesting is the frequency is skewed towards words that are used more higher, but this is less visible when it comes to women's clothing. And we can also see the word types are significantly different. However, this will require more analysis in the future. We also use machine learning with the sklearn kit to create an algorithm that took in the words of review and returned the predicted score based on those words. We found the MSE in the tech category was between 0.54 and 0.64, and the clothing category is between 0.85 and 0.92, suggesting that the predictive power of the reviews on ratings is more accurate for tech products than for clothes.
Okay, so to perform our natural language processing, we use a library called CSE. And so it has a variety of features, which include tokenization, which segment text into words and punctuation marks, and it stores it into a doc object that is defined by CSE itself. It also utilizes part of speech tagging, which assigns words their word types, such as a verb or noun. And there's also loads more. Now, CSE utilizes machine learning models to operate some of its features, such as by looking at the grammatical structure of the sentence and also the contextual location in which the token appears. Now, so we were able to create 8 types of bar charts, or excuse me, 8 bar charts, which looked at the Amazon tech products data set, and it looked at the ratio, the rate of occurrence of each word type within a given review. So say if a review had 100 words and you had 20 of them as nouns, you would see a ratio of 20%. And so what's interesting about this is that we can find that like across the review ratings, right, each of the word types themselves remain quite consistent, but across the different word types, the ratios are pretty much all over the place. Now, so as far as our conclusive results are concerned, so from our research, we can conclude 2 things. First is that our multifaceted approach is a good start to understand the scope of the issue, but more research does need to be done to figure out the causation. And that there's a significant difference in the factors of our approach across the product categories. So these suggest that we have a good start to understanding the scope of the issue, but that our work can be expanded on to create a more accurate and nuanced prediction in the future.
So here is our future work plan. So as an expansion to our work could include learning about more the complexity behind CSE's other features. This may allow us to perform different types of analysis that could provide synergy with what we have thus far. One such synergy would be the analysis of single words to create a sentiment analysis. This could then tie in with an expanded machine learning algorithm to increase the predictive power of our model. This subject is ripe for further examination, and our analysis will form an excellent basis for future expansion. Thank you.